Hi everyone. To get us started with Chapter 2, we're going to be talking about average rates of change in secant lines. So these are things you have definitely learned about before, but we just want to go over what really we mean by average rate of change and secant lines so that we're all on the same page and have a really solid common understanding. So in terms of the learning targets, our first target is I can determine the average rate of change of a function over a given interval, and then we'll be talking about I can write the equation of a secant line when given a function and an interval. So let's go ahead and jump in with average rates of change. So we're going to be working with our four different representations, verbal, graphical, numerical, and algebraic. So in terms of our verbal representation or our definition, when we talk about average rates of change, we're really just talking about the slope between 2 points. Okay, so when we think average rate of change, we just think slope. Now, graphically what this looks like. So it says use the graph of f of x equals x squared to find the average rate of change over the interval from -1 to -2. Now, the important thing to remember here is this is not a point. This is an interval, right? So it's really saying from one x value to another. So x1 to x2. So if I want to find the average rate of change here, we said it's the slope between 2 points. Well, my first point comes when my x-coordinate is -1. On the graph here, my y-coordinate is +1. So there's 1 point. For my second point, it's where my x-coordinate is 2, and for this particular function, then my y value is 4. So if I have a graph and I'm talking about slope, I'm just talking about my rise over run. So in this case, our rise, we'd be going up 3, and our run would also be +3. So our average rate of change we're going to use rise over run, which in our case is 3 over 3, or just 1. So again, the big idea is average rate of change is just a slope, and graphically we're going to use rise over run to show that. Now let's go ahead and look at a numerical representation or table here. And again, the question is the same here. Our question is to use the table to find the average rate of change. Again, we're over the interval from -1 to 2. So now when we're finding the slope, we're going to write our slope as f of, let me write that over again, sorry about that. F of b minus f of a over b minus a, when we're finding that average rate of change. Now, when we write that, to get a and b, we're really looking at our interval right here. So my -1 is my a, and my 2 is b. So in this case, if I want to find the average rate of change, or the slope, I'm going to do f of b, which is 2, minus f of a, my a is -1, and then all over 2 minus a -1. So now we can use the table. F of 2, my c is 4. F of -1 is 1. I have 2 minus a -1, that's just 2 plus 1, which is 3. So I have 3 over 3. And again, my average rate of change is just 1. All right, so now the last way we could be asked to find the average rate of change here is if we're given the actual function itself and the interval. Okay, this is going to function a lot like what we just did. We're still finding that slope using our f of b minus f of a over b minus a. My interval here is where I get my values of a and b. But now to be able to find out these values, I just have to do some calculations here. Right? These are simple, but just to illustrate the point, if I want to find f of b, in this case that's f of 2, I would plug in 2 to my equation, and I would get 4 for that value. For f of -1, I would have quantity of -1 squared, which would give me a positive 1. Now that I've calculated those values, I could plug them in into my slope here. And again, we would get the same values we had before. 4 minus 1 over 3, which is 3 over 3, or just 1. The big thing we want you to understand here is when we're talking about average rate of change, we're just talking about the slope between 2 points. We haven't learned any new technique here, just really more a new way of describing what we already knew. All right, so let's go ahead and look on the next page. Here we're really going to look at secant lines and how we can represent the secant lines. So for a secant line, all we're talking about in terms of a definition is just a line that goes through 2 points on a curve. And when we look at a graph, we'll do a representation of that. Okay, so what we're trying to do is write the equation of this line that goes through 2 points on our curve. Now, since we're going to be writing the equation of the line, we're going to make a note here that we're going to write the equation of the secant line in point slope form. So whenever I'm asked to write the equation of a secant line, I'm going to need 2 things. So to write the equation of the secant line, we need 2 things. The first is a slope, and we're going to call that M, and the second is a point. And we can refer to that as x1, y1. So then just as a quick refresher, when we're talking about point slope form, that's going to look like y minus y1 equals m times the quantity x minus x1. So point slope form will be something we use a lot right now as we're working with secant lines, and then as we learn about other types of lines, we're going to be working with that equation a lot. All right, so let's look at what this looks like graphically. So we're going to use the graph of f of x equals x squared to write the equation of the secant line over the interval from -1 to 2. So again, these are giving me x values. So when x is -1, my function value is 1. That's my point right here. When x is 2, my y value is 4. That's my point there. And what I'm going to do to get my secant line, the graphical representation, is I'm just going to connect those 2 points. Okay, so there is my secant line. Again, just the line that goes through those 2 points on the curve. So if I'm going to write the equation, we already said we need 2 things. We need the slope, and we need a point. So for slope, we found this on the first page. We can use our rise over run. So my rise is 3, my run is 3, so my slope is 3 over 3, or 1. And then for my point, I actually have a choice here. So we could write this equation 2 different ways. Let's say I started with this x value. When x is -1, we found our y value is a positive 1. So if I use this information, my equation could look like this. Y minus my y value, which is 1, equals my slope, which is 1, times x minus my x value, which is going to make that x plus 1. So that's one possible equation of the secant line in point slope form. However, because we're given an interval, we could also write it a different way. We still need our m and our point, our slope, and our point. Our slope is 1. But I could also choose to use the point whose x-coordinate is 2. So if I chose that point, my x-coordinate is 2 and my y-coordinate is 4. So now my equation would be y minus 4 equals 1 times x minus 2. Either those equations would be correct. They're actually equivalent if we were to translate them into slope-intercept form. So I just want to make the point that either one of these equations would be correct for the equation of the secant line. Okay, now numerically, right, if we're going to write the equation of the secant line, again, we would need two things. We need a slope, which again, to reinforce the vocab, is our average rate of change, right? We need to evaluate the values at each endpoint, so f of 2 minus f of negative 1 over the change in x, which is 2 minus a negative 1, and we've already seen that this is equal to 1. Again, to get my point, I have two choices here. If I take my x-coordinate, negative 1, I know that when x is negative 1, my y value is 1, and then I could write my equation y minus 1 equals 1 times x plus 1. All right, the last way again now is if we had our algebraic representation. So we're given the actual function and an interval. So again, the idea, we're still finding the same information. Our slope, which is our average rate of change. We would find the same way we've been doing, which would be our f of 2 minus f of negative 1 over 2 minus a negative 1. Sorry about that. We would use our equation to evaluate those. Since we did that, I won't write it all out. That is 1. And then again, to get our point, we could take our x-coordinate, which is negative 1. To get the y value, I would substitute negative 1 in for x, and I would get a y value of 1. And again, we come back to the equation, y minus 1 equals 1 times x plus 1. Now again, usually I wouldn't put the 1 here in front, but just illustrating that that's a holder for that slope. So again, we recognize that we've learned about slopes and secant lines before, but just wanted to go through those four representations, since in practice you'll have to be able to find those rates of change and equations given different representations. All right, so you've got some practice to do on page 3. Good luck. Thanks.